One of my favorite engineering quotes is, engineers don't make mistakes, they make revisions. I make mistakes, but anyway, the prototype gives you an opportunity to make revisions to your design after actually seeing it being applied. And this is what I want to talk about here for a few minutes. What you're looking at is the very first prototype I ever built, and I keep this thing around the shop because it's a constant reminder of where I started. When I built this, I knew nothing about designing with linkages. In fact, I actually made the first version of this out of cardboard so that I could move the pins around to figure out how long each of the linkages needed to be. Once I figured that out, I was able to build a prototype out of wood like this to give me the confidence to build a full-scale model. I also learned during that process that the holes needed to have a little bit of slop in it and a couple things like that along the way. Probably my favorite thing about making prototypes is that they give you hindsight. Since building this, I've built a whole bunch of prototypes and every one of them has yielded some helpful information. This guy is no exception. In fact, the thing that I'm about to show you now, I'm actually a little embarrassed to show it to you because I really feel like I should have noticed this from the beginning, but I didn't. I did not notice until I was actually putting the components inside the space to make sure everything fits. Let me show you what I mean. Before I can explain the problem with this design, I need to give you some background information. This project is a little bit different from what I normally do on this channel. Nearly everything I've made up to this point has been with the primary goal of making educational videos on YouTube, whether it's related to DIY level stuff or full-on engineering. Even that giant robot you see behind me was built with the intent of making YouTube videos about the project and how one might go about designing and building something like that. And every time I release one of these videos, I get a flood of emails from you guys saying, hey, you should try to turn that into a product. Or Jeremy, would you help me design and build my idea? So one day I got several of my like-minded engineering buddies together and I said, what if we started a research and development business where we could take all these ideas that we're always kicking around and turn them into real products? And what if we went one step further and made this available to other businesses so they wouldn't have to try to recruit all these different skills when they want to do research and development? The basic premise is we not only do the engineering, we can also build working prototypes. I'm going to talk more about why the prototype is so important in just a little bit. The device you see behind me today is one of those projects. The goal is to develop an autonomous line painting robot. This is not a new idea by any means. There are several companies making something like this. The reason you don't see your local high school using these robots is because the price point is still pretty high across the board. Building the prototype is by far the most exciting part of this process for me. There are a surprising number of things that you just don't even pick up on until the product is actually live and in front of you. Even though I'm going to leave a few things out for obvious reasons, there is ample opportunity to walk you through the design process for this project. And especially, I get to talk to you about prototypes, which is one of my favorite topics. So let's start there. Here's the basic layout. Back here in the back, I've got two electrical boxes to separate certain components. We've got a rather large DC to AC inverter. Very early in the design, my intent was to put all of the electrical in the back. Once I sized all the components and realized I needed this rather large inverter, I decided to move this up to the front. My thinking being I can shorten this cart a little bit, taper the back end, and reduce the weight of the whole cart. So that was the basic premise. I spent most of the rest of the design with this guy sitting right here and with my paint sprayer sitting on top of it. And I hope you are starting to see the problem with this issue. What if my paint sprayer leaks? This seems like an obvious no-brainer in hindsight that something that's going to have paint and occasionally water running through it when you rinse it out and a bucket of paint right here next to it. Why would you put all of that right next to your inverter? Like I said, seems obvious in hindsight. I am a little bit embarrassed and ashamed to even tell you that I did that, but I did. Here's a good place to point out that pride is the absolute enemy of innovation. The faster you can admit that you missed something and got it wrong, the quicker you can get on to a working solution. It's always a challenge to show any mistakes on the internet because, you know, internet. My true hope in sharing this with you is that you'll realize that you are going to make mistakes and that's perfectly normal. Anybody who tells you they never screw up is somebody who's simply lying to you. My temporary solution for this particular design is going to be to build in some sort of splash guard / bulkhead here and just run all my cables through that. Of course, I need to make sure I leave enough airflow for the inverter to cool itself, but I think that's going to be the easiest way to separate the paint sprayer as well as the bucket from the electrical system that we have here. I say this particular design because ideally we'd want this whole unit to run on DC, but it's difficult to find DC versions of the particular parts that we need. And if we're going to be making this thing a scale, we don't want parts that are difficult to find. Some of these things we may end up inventing ourselves, but those are details that will come later. For now, we're going to see how this functions with an inverter and if we can possibly downsize the inverter in the future. There's a couple other lessons learned here, but I also want to show you the whole build process. So let's start a quick build montage and I'll tell you more about this along the way. I didn't start screen recording this project until I definitely knew I was going to be able to share it with you guys. It's a rare opportunity to see the early stages of engineering when errors abound and things are likely to change. The stage you're looking at now is after I'd pretty well defined where everything was going to sit and I'm just working on the enclosure. The pole you see sticking straight up is going to be supporting the GPS receiver, and there's going to be a brace holding that pole in place, and I think you'll see the first version of that here in a little bit. If you want to learn more about my 3D modeling techniques, I've got a pretty extensive video that I released just before this one, which shows this same CAD model in great detail, going over how I structure my models, how I use the planes, and some tips and tricks for modeling faster. I'll be sure to put a link to that for you in the description. At several stages during the modeling process, I will stop and just spin the model around and think about how it's going to be fabricated. And it was at this point that I realized that square tubing was going to be better. Not only is square tubing going to make the whole structure stronger, but it should be easier to assemble and weld as well. That's because it's going to significantly reduce the number of 45-degree bevel cuts, and there'll be more surface area for fillet welds, which are much easier to lay down. Every little thing that I can do to make the fabrication process cheaper in the long run is going to lower the cost of my product. These builds are not normally done by me or in my shop, so there's several compromises I had to make. For example, this plate would normally be cut out on a fiber laser, but since I wanted to film all of this in my shop and do it myself, I am doing it on a wood router. This is definitely not the ideal tool, but it gave me a chance to do the CAD, CAM, and most importantly, I can film in my shop. And this is one more compromise I had to make, which is using my aluminum MIG welding gun instead of TIG welding. TIG welding is definitely a better process for welding thin aluminum like this, but I'm working with the tools that I have. And as a result, I struggled a bit. This metal is really thin. This is only a 1/16 of an inch. I need to tinker around with my temperature and speed a little bit here. Try to get that dialed in before I weld everything up. That one looks better than that one, but that's still not great. I did end up ordering the upgrade to allow my machine to do TIG welding. Now I just need to learn how to TIG weld. No doubt about it, this has definitely been one of the hardest things I've tried to weld in a long time. Granted, I don't consider myself to be a professional by any means. This is just DIY level welding. But here is a great example of the challenges that I've been facing. So I've been mostly welding this 1/16 inch thickness, but here this is an 1/8 inch thick and this is a 1/4 inch, so about 3 millimeters and 6 millimeters. And look at that weld. Here the machine is set up better for the 1/16 inch material, and you can see it's not penetrating at all. It's just sort of lumping up on the top, and the weld is pretty ugly. On this side, after adjusting the settings, allowing for more heat to go into the plate, you can see you get much better penetration. That weld is nice and flat. That looks so much better. But doing that consistently over this whole part has been kicking my butt for 2 days now. Fortunately, this is just a prototype, so I'm not terribly worried about it looking great or being perfect. I really just need the structure to be strong enough to prove out the design and make sure we have something that functions the way we want. I'm gonna grind out this ugly weld because I can't stand looking at that. And let's give that a try again. As I mentioned earlier, this is a custom CNC table saw that I built, and there's a whole video on my channel about it. I'll put a link in the description for you. This table saw does have a riving knife, but I removed it so that I could score the plate before I cut all the way through. I feel like this goes without saying, but you don't normally cut aluminum on a table saw designed to cut wood, so copy me here at your own risk. Alright, moment of truth. Solid light, that's good. Hey. Okay, forward and backwards works. Wait, that. I got them inverse. Okay, so right is left and left is right, but that's easy to fix. Man, look at that. Man! Well, I can say one thing for sure. We've got more than enough power. After playing around for a few minutes, making sure everything works, I decided it's time to get back to work. Well, I think I might actually be ready to go finally. Man, it's warming up in here. All right, that's better. The stuff that I'm using today is called MS9399. Basically, this is a flexible adhesive. If you've ever seen those commercial trucks with the vehicle wrap on it, this is what they use to install those panels. There are many reasons why you'd want to use this instead of just welding the panels on. Number one, this stuff is flexible. Your vehicle's outside, they're going to be temperature extremes. So this allows the panel to stretch and move around a little bit. It works on a wide range of materials. So if we want to bond aluminum to wood, we can. If we want to bond painted surfaces or even plastics, we have that option. It's pretty easy to apply manually, but there's no reason you couldn't automate this process as well. And then also, this is a lot easier to remove. Even though the bonding strength is well over 400 PSI, you can still take a razor blade and scrape this stuff off. And I'm very likely to crash this thing eventually. I want to be able to get the panels off. Of course, you can use fasteners as well, but that doesn't look nearly as good once you put the vehicle wrap on top. Probably the biggest lesson I've learned from working with the LOCTITE engineers is that they make all these different adhesives so that they can be tailored to specific applications. Some of them set up almost instantly like super glue, but you wouldn't want that in this case because if the guy puts the panel on a little bit crooked, he can't get it back off. So the stuff that I'm using today, you need to apply it within about 5 minutes, but then it takes about 2 to 3 hours for it to fully set up to handling strength. And then there's a 24-hour curing time before you can allow this thing to be out in temperatures below 60 degrees. The engineers did recommend I use some sort of temporary fixturing, which could be removed after the first 20 minutes. I like the double-sided tape because it prevents squeeze out and I can leave it in place. The surface prep is pretty easy. You just wipe down the bonding area with an alcohol-based cleaner. Removing any residue or debris will ensure the best performance. I'm gonna let the adhesive set up and then I'll come back, peel the plastic off and put the trim pieces on. I'm going to put the data sheet for this product in the description, but I actually recommend you just talk to an adhesive expert. I'll put a link in the description where you can consult with one of them for free. That way they can tell you which product best matches your application. Now's a good opportunity to say thank you LOCTITE for sponsoring this video today. To me, adhesives is one of those tools that's really easy to forget that you have. But when you have the right application, it is amazing the difference that it can make. My suggestion is simply to keep this in mind as one of those tools that's in your toolbox. And when you need it, you pull it out. At this point, I need to go back and design the bulkhead, make sure I get that installed. After that, we can install the GPS, the paint unit, and we'll be ready to spray some lawns on the ground. I do have a couple more pieces of advice for making prototypes. You can often save a lot of money by scaling down your design, but pay attention to the scale that you use. Don't pick an arbitrary number. For example, if you have a long pipe with a thin wall and you try to scale that down, then the wall can only be so thin before it's entirely useless. It's hard to give a lot of specific advice here without knowing exactly what you're making, but it is worth pointing out that you should be intentional about the scale that you pick. The first version of this cart, for example, was a little bit smaller, but not by much. My main goal with that first design was just to quickly get to a proof of concept. Instead of using GPS, I was using something along the lines of Dead Reckoning. It was essentially a free-roaming CNC machine that was running CNC software mobily on the cart. There are a lot of issues with that, which is why we're not going to use that in the final design, but I did have an autonomous rover that was following a predetermined path. The other important thing about that was that I used cheaper materials. This is a key factor for two reasons in making prototypes. Number one, using cheaper materials will often reveal weaknesses in your design. If you're making it out of cardboard, for example, cardboard is inherently weak, but it can be shaped to maximize its strength just like any other material. For example, I received an order the other day. Where'd you go? The item that I ordered was packaged with cardboard. And look at that. Who doesn't recognize that iconic I-beam shape, which makes this inherently strong? We all recognize cardboard as being inherently weak, but this particular shape is unbelievably stiff and strong. Using cardboard like this is an opportunity to figure out where your design could be stronger simply by improving the shape. If you pay attention to little things like that, you might find out that you can use thicker material if you're using something strong like steel, or you might find that you can use an inherently weak but cheap material like plastic to design your product. The key takeaway here is the shape matters as much as the material. Prototyping is one of the ways that you can experiment with figuring out the optimal shape and material combination. I do have another video on my channel where I talk a little bit more about building prototypes and I walk you through me actually building one. I'll put a link to that video in the description. If you're wondering about the self-driving car series, I've decided to cover this project in lieu of that one. If you want to know more about why I've decided to switch those out, I'll put my Twitter and Instagram handles right here, and you can follow me on the other social media platforms where you'll see more details about that. I'm really excited about this new business venture that we've been working on. We've managed to pull together a pretty impressive collection of skill sets, and I'm looking forward to the cool things that we're going to be able to produce. If you want to reach out, you can. So I'll leave some information in the description for you. Anyway, I look forward to seeing you in the next video, and thanks for watching.